You know, when we talk about the most powerful machines ever built by human hands, we usually assume their functions are strictly predictable. Like, you build a massive rocket, it goes to space. You build an industrial laser, it cuts through titanium.
Right, they do what they're built to do.
Exactly. But what if you built a machine so immensely powerful, I mean, so far beyond standard human comprehension, that its function wasn't just to bend the rules of physics, but to actively rewrite reality itself?
Well, I mean, it sounds exactly like the setup for a summer sci-fi blockbuster.
It really does. But today, we are taking a deep dive into a very real, tangible event that literally just happened. So on June 29, 2026, the Large Hadron Collider at CERN, that colossal 27-kilometer ring of superconducting magnets buried underground in Switzerland, it just went completely dark. It was officially shut down.
Yeah, long shutdown number 3.
Right. And our source material today is a remarkably detailed transcript from a YouTube video on the Mysteria Archive channel. The video is titled CERN's Time Machine, the shutdown nobody can explain.
And the creator of this video, they put together a narrative that makes some incredibly bold claims about the true nature of this shutdown. They kind of weave together actual published physics papers, foundational principles of quantum mechanics, officially acknowledged data anomalies from CERN, and, widespread internet theories.
Yeah, and the ultimate conclusion they point to is that something went fundamentally wrong with the flow of time itself, which is a wild claim.
It is.
But before we go any further, I really want to make one thing crystal clear to you listening right now. This deep dive is completely impartial. We are not here to endorse the theories, the worldview, or the speculations presented in this source video.
Right, no sides being taken here.
Yeah, exactly. Our mission today is strictly analytical. We're going to unpack the fascinating narrative this creator has built and explore how they use real-world science to fuel this mind-bending speculation. So, okay, let's unpack this. To understand the internet hype around this recent shutdown, which, as you said, CERN officially designates as long shutdown. Number 3, they are warming the machine from its operating temperature of 1.9 Kelvin all the way up to room temperature. But we need to establish some context for that.
Yeah, and that 1.9 Kelvin figure is actually a great place to start, just to grasp the sheer scale of what we're talking about here.
It's cold, right?
Oh, it's beyond cold. 1.9 Kelvin is about minus 271 degrees Celsius. To put that in perspective, the ambient temperature of the vacuum of deep space is about 2.7 Kelvin.
Wait, really?
Yes. So when the Large Hadron Collider is actually running, that 27-kilometer ring is literally colder than outer space.
That's just hard to wrap your head around.
It is. It's one of the most extreme environments in the universe, and it's just sitting right beneath the French-Swiss border.
Which perfectly sets the stage for the first major piece of evidence in the video. The creator argues that to understand this current shutdown, we actually have to go back to 2007. This was a year before the machine even turned on for the first time.
Right, before any protons were smashed.
Exactly. And they point to a very real, highly technical physics paper published on arXiv, which is like the main preprint server for physicists.
Right, and it is crucial to understand the pedigree here, because this wasn't written by, amateur bloggers connecting red string on a corkboard. It was authored by Irina Arefyeva and Igor Volovich.
And they are serious scientists.
Very serious. They are mathematical physicists at the Steklov Mathematical Institute in Moscow. I mean, their entire career focuses on the very bedrock of reality, quantum gravity, string theory, the really heavy stuff. And they published this paper with a title that left absolutely zero room for ambiguity.
Yeah, the title is what gets me.
It was simply called Time Machine at the LHC.
Not a what if, not like a theoretical exploration, just time machine at the LHC. So what exactly were these two physicists arguing before the machine even powered up?
Well, their argument relies heavily on the energy scale of the collider. The LHC was built to smash protons together at unimaginable speeds, achieving an energy level measured in tera-electron volts, or TeV.
TeV, right.
Yeah. So Arefyeva and Volovich proposed a mathematical model showing that if quantum gravity operates at this specific TeV scale, the sheer concentrated force of these proton collisions could theoretically bend spacetime so intensely that it creates what physicists call closed timelike curves.
Okay, closed timelike curve. That is a very heavy, jargony phrase. Can you break down the actual mechanics of what that means? Because the video treats it as a literal time machine.
Well, I mean, it essentially is. Closed timelike curve is a legitimate mathematical solution to Albert Einstein's field equations of general relativity.
Okay.
So imagine spacetime as a flat sheet of rubber. Normally, you move forward across that sheet in a straight line, That's the normal progression of time.
Making sense so far.
But if you drop something unfathomably heavy and energetic onto that sheet, the rubber warps and stretches. If it warps enough, the math suggests the path of time could bend so extremely that it loops back onto itself, basically connecting the future to the past.
Okay, so it's not like a shiny DeLorean with a flux capacitor. It's just a localized loop in the fabric of reality itself.
Exactly.
To put that in plain English for you listening, it's less like a sci-fi vehicle and more like finding a typo on page 50 of a book you're reading. And mathematically, the act of fixing that typo forces the ink on page 1 to completely change its shape.
That's a great way to think about it. And the paper even argued the probability of producing these time loops would be roughly comparable to the probability of the LHC producing microscopic black holes.
Which was a whole other panic back in the day. But what fascinates me is the response.
Right. What's fascinating here is the scientific community's reaction, or rather, the distinct lack of panic. When two respected physicists publish a paper claiming the largest machine on Earth might punch a hole in causality, you might assume the scientific establishment would hit the emergency stop button.
It's like someone warning, hey, this oven might open a dark portal, and the scientific community responding, yeah, let's keep an eye on that while you proceed to bake the cake.
Pretty much. They didn't panic. They engaged with it purely mathematically. They wrote response papers, debated the geometry of the space-time loops in journals, discussed it at conferences, and then the conversation just sort of faded away.
Just faded away.
Yeah. The LHC powered on in 2008. The paper got buried under thousands of newer publications, and everyone just went to work. The paper was never retracted, and the math was never disproven.
That is wild to me. As an outsider, why would the scientific community just quietly move on? If this was recognized as a legitimate mathematical possibility, like why aren't people freaking out?
Well, because in the realm of advanced quantum mechanics, time behaving strangely is not a deal breaker. It's actually a known, expected feature of the landscape. Yeah. To understand why that 2007 paper wasn't immediately laughed out of the room, we have to look at how causality actually works at the subatomic level. And the video brings up a concept called retrocausality.
The idea that the future can directly influence the past, which, I gotta say, sounds like magic.
It does sound like magic, but it's verified science. The video points to a landmark concept proposed by physicist John Wheeler in 1978, known as the delayed choice experiment.
Okay.
This is textbook physics. It's been successfully performed in labs around the world. To understand how it works, imagine shooting a single particle of light, a photon, at a barrier with two tiny slits in it.
Oh, the classic double slit experiment. We've probably all heard of that one.
Exactly. Normally, if you don't observe the photon, it acts like a wave and ripples through both slits at the same time. But if you place a camera right at the slits to see which one it goes through, the photon suddenly acts like a solid particle and chooses only one slit.
Because the act of measuring it changes its behavior.
Right. But Wheeler asked, what if you wait until after the photon has passed the slits, but before it hits the back wall, to decide whether to measure it?
Wait, so the photon has already made its choice? It already went through as a wave or as a particle?
That's the logical assumption. But when they perform this in the lab, if they randomly choose to turn the detector on at the very last microsecond, the photon hits the back wall as a particle.
What? So it's as if the photon knew it was going to be measured in the future and retroactively went back in time to change how it passed through the slits.
Yes. The measurement you make in the present literally alters the physical path the particle took in the past.
I really want you listening to sit with the weight of that for a second. The arrow of time, the strict, unbreakable rule that a cause must always happen before an effect, is not a universal law. At the quantum level, the future actively reaches back and edits the past.
It's mind-bending. And historically, we've only observed this retrocausality with single particles in highly controlled, low-energy lab environments. But the video asks a pretty terrifying scaling question.
Right.
The LHC doesn't collide single photons. It collides trillions of protons, moving at 99.9999% the speed of light. And it does so at an energy level of 13 tera-electron volts.
Yeah, and let's give some context to that 13 TeV number too. Because to a physicist, that number is staggering. 13 TeV is roughly the kinetic energy of a mosquito flying through the air.
Which doesn't sound like a lot.
No, it doesn't. But in the LHC, that amount of physical energy is concentrated into a space that is 1 trillion times smaller than a single grain of sand. It's a density of energy that hasn't existed naturally in the universe since the literal moments after the Big Bang.
Precisely. So the video's premise hinges on this core idea. if retrocausality is a proven fact for single low-energy particles, what happens when you concentrate the unprecedented energy of the Big Bang into these quantum events?
Are you amplifying it?
Exactly. Are you amplifying that retrocausal effect? Are you creating an environment where the future isn't just leaking into the past for a single photon, but for the fabric of reality itself?
Here's where it gets really interesting, though. If we are moving from a confirmed microscopic lab experiment to a massive, reality-altering macro event at CERN, there has to be a mechanism we can track, right? If causality is actually breaking down inside that 27-kilometer ring, where is the physical proof?
Well, according to the creator of the video, the proof is hiding right out in the open, buried in CERN's collision data. Or, more accurately, in the missing data.
Right, this is where the video dives into the whistleblowers and the data anomalies. It references these unverified forum posts from people claiming to be former CERN data analysts and contractors.
The anonymous forum posters.
Yeah. And these posters describe a very specific, deeply unsettling phenomenon. They claim that the instruments at CERN were recording collision data with timestamps that completely defied linear time. Like the digital readouts of the collisions were appearing in the data stream fractions of a second before the protons had actually collided.
Right, the accounts allege that the data was essentially arriving from the future, prompting CERN to secretly develop protocols specifically designed to handle this so-called pre-arrival data.
Now, I have to push back hard on this specific part of the video's narrative.
Oh, absolutely.
We've all been on the internet long enough to recognize a classic trust me bro myth. An anonymous forum poster claiming they worked at a top-secret facility and saw the future is the exact kind of creative writing exercise you expect to find on a late-night conspiracy board. Without verification, we just have to view that as modern folklore.
This raises an important question, though, because while you are completely right to dismiss the anonymous forum posts, the video doesn't actually rely solely on them. It pivots beautifully to official public records.
The actual missing data.
Right. CERN officially acknowledges that certain collision datasets are missing or have required massive unexplained recalculations.
Though, to be fair, CERN's official explanation for missing data is always detector calibration issues, software bugs, or hardware limitations. Which, I mean, is completely logical. You're running the most complex machine ever built. The software is going to crash occasionally.
True, it's completely logical. But the video highlights an intriguing pattern. These data gaps don't appear evenly spread out like random software noise.
They don't.
No, they specifically cluster around the highest energy collisions.
Oh, wow.
The exact types of collisions where, according to that 2007 Areva, Ava, and Volovich paper, those closed, time-like curves would be most likely to form.
That is a very convenient coincidence.
And this brings us to the most celebrated discovery in CERN's history. The July 2012 announcement of the Higgs boson.
Ah, the God particle. The missing puzzle piece of physics that gives mass to everything in the universe. That discovery was global front-page news.
It was huge.
But what the public didn't see is that the announcement was delayed for months. The official reason was data verification, which, again, makes total sense. You don't announce a century-defining discovery without checking your math 10 times over.
Absolutely not. But the video points out that during this delay, there were intense murmurs in the physics community about excess events.
Excess events?
Yes. These were essentially rogue data points. They were collision results that simply didn't fit the expected mathematical pattern for the Higgs boson.
So what did CERN do with them?
Officially, CERN eventually categorized them as statistical noise or background fluctuations. But independent researchers noticed that these anomalies clustered tightly around a specific energy range, an energy range that mathematically matches theoretical predictions for a particle called a Higgs singlet.
Okay, we need to explain the mechanics of a Higgs singlet because this is where the physics gets incredibly weird and it ties everything together.
It really does. So in quantum field theory, there is an interpretation developed by Richard Feynman and Ernst Stugelberg regarding antiparticles. It states that mathematically, an antiparticle is completely indistinguishable from a normal particle that is traveling backward in time.
Okay, stay with us here.
Yeah, it's dense. But basically, a Higgs singlet is a hypothetical particle that has no charge, meaning it acts as its own antiparticle.
So if it's its own antiparticle, it could theoretically oscillate, like it could move forward in time and then slip backward in time.
Exactly.
Meaning if you create a Higgs singlet in a collision, it might travel backward through the temporal dimension and hit your detector before the collision actually happened.
Exactly. The video suggests that in 2012, CERN found something they couldn't explain, a cluster of data pointing toward time-traveling particles, and quietly swept it under the rug of statistical noise, just to focus on the triumph of the standard Higgs boson.
Which, I mean, isn't that official data gap and those unexplained excess events infinitely more compelling than some anonymous forum poster? It's the actual published science that makes this unsettling.
Absolutely.
Yeah.
In science, what researchers choose not to talk about is often just as revealing as what makes the headlines. They found data hovering exactly where time-traveling particles should theoretically be, and they just moved on.
Yeah.
But if we follow the video's logic to its ultimate conclusion and assume that particles actually were traveling backward in time and altering the past, we have to ask a human question.
Right. How would we experience a shift in the timeline? The video calls it the reality bleed, and it connects the high-level physics of the LHC directly to a cultural phenomenon that you listening have almost certainly heard of or maybe even experienced.
Yeah.
The Mandela Effect.
Right, the Mandela Effect.
Yeah.
For context, this was a term coined in 2009 by an author named Fiona Broome. She, along with thousands of unconnected people online, shared a vivid, highly detailed memory that Nelson Mandela died in a South African prison in the 1980s.
They remembered news coverage, funerals, speeches.
Yes, but none of it happened. He was released in 1990 and became president. It was a mass-shared false memory.
And the video creator maps the timeline of the Mandela Effect directly onto the operational timeline of the LHC, and I have to admit, the dates are surprisingly tight.
They really are.
The LHC's first proton beams circulated in September 2008. The first actual high-energy collisions happened in November 2009, which is the exact same year the term Mandela Effect was coined.
But the linchpin of their argument is 2015.
Right, the restart.
In 2015, the LHC restarted after a 2-year shutdown for upgrades. When it turned back on, it was running at nearly double its previous energy, hitting that staggering 13 TV mark.
The mosquito energy.
Yes, and 2015 is the exact year the Mandela Effect community says things went into overdrive.
Wow.
The creator mentions their own memories shifting around this time, the classic examples, like remembering C-3PO having 2 gold legs in Star Wars instead of 1 silver one, or remembering the character Dolly wearing braces in the James Bond movie Moonraker.
It's permeated pop culture so deeply that we have shows like Netflix's Umbrella Academy treating shifting timelines as a given. The theory the video proposes is that these sustained hyperenergetic collisions at CERN are not just passively studying particles, they're actively, subtly altering the quantum field of reality itself.
Right.
It's not a massive cinematic timeline change where the world ends. It's an accumulation of tiny microshifts. A brand logo changes here, a movie detail shifts there, all because the past is being mathematically rewritten at the subatomic level.
Now, to be intellectually honest, the video creator freely admits that correlation is not causation.
Sure.
The mid-2010s also saw the absolute explosion of algorithm-driven social media. The most logical, grounded explanation is that mass internet communication just allowed people with similar, faulty human memories to find each other and reinforce their mistakes.
Yeah, I want to stop and ask you listening to really think about your own false memories, like the Berenstain Bears spelled with an A instead of an E, or the Monopoly Man having a monocle. Are we just looking for a cosmic sci-fi excuse for our incredibly fallible human brains? Or is the timeline correlation between the LHC powering up to 13 TV and this sudden massive divergence in human memory too perfectly aligned to completely ignore?
Well, it's a compelling narrative because of the philosophical mechanism behind it.
Yeah.
If reality did shift, if a localized edit was made to the timeline, our physical brains and our memories would logically update to match the new timeline. We wouldn't know anything had changed.
Right, because our brains are made of the same matter that just got rewritten.
Exactly. Unless the update wasn't perfect.
Oh.
The Mandela Effect community claims that these shared false memories are actually residual memories. It's the idea that human consciousness, which we still barely understand, might sit slightly outside the purely physical quantum field. So when the physical reality updated, some consciousnesses retain the old data.
That is wild. Which brings us directly back to the reality of today and long shutdown number 3. The massive machine just went dark on June 29th. So the obvious question the video poses is, does reality stabilize now? Like, if 13 TeV collisions were causing these micro instabilities and causality, does cutting the power let the timeline settle back into a normal rhythm?
The video suggests a few possibilities. One is stabilization. Another is that the damage, if real, is cumulative. You can't unring a quantum bell. The loops in space-time are already there.
Right.
But the most symbolic element the video focuses on is a very real piece of art sitting right on CERN's campus, the statue of Shiva Nataraja.
Oh, this detail is so striking to me. It's a massive, beautiful statue that was a gift from the Indian government in 2004. And in Hindu cosmology, Shiva is the lord of time and cosmic cycles. He is depicted engaged in the Nataraja, which is the endless dance of creation and annihilation of the universe.
Yeah.
The video uses it as a metaphor just because the LHC is powered down, the dance of Shiva continues, the cosmic cycle doesn't stop.
Right. And if we connect this to the bigger picture, the shutdown of the LHC isn't the end of CERN's story. It's just a brief intermission.
Yeah, because while everyone on the internet is focused on the LHC going dark, CERN has already published the blueprints for what comes next.
The Future Circular Collider.
Yes, the FCC. And the physical scale of this new machine is hard to even comprehend.
Yeah.
The LHC is 27 kilometers around. The FCC will be 91 kilometers around.
It's massive.
It's going to pass deep underground beneath 3 different countries. It's slated to turn on in the mid-2040s, and it is designed to operate at roughly 3 times the power of the LHC.
And the explicit, documented goal of the FCC is to study new physics beyond our current standard model. But if you read the dry, careful language of their technical documents, one of their primary targets is the study of TeV-scale quantum gravity.
Wait, which is the exact mathematical threshold from that 2007 Arefjeva and Volovich paper?
Yeah.
The very energy scale theorized to bend spacetime enough to produce closed time-like curves. So, what does this all mean? If every time we build a progressively bigger machine, we uncover something dangerously strange that we didn't expect, like unexplained data gaps or theoretical particles moving backward through time, at what point do we stop?
That's the million-dollar question.
Right. Do scientists ever step back and ask if a 91-kilometer collider is a risk we actually want to take? Or does the drive for discovery just override the caution?
That is the unspoken tension hanging over modern particle physics. I mean, the pursuit of fundamental knowledge is baked into human nature. But if that pursuit requires manipulating the raw, concentrated energy of the Big Bang, we're operating in a realm where the consequences are entirely theoretical right up until the exact moment they become permanent reality.
And that leads right into the most unsettling core argument of this entire deep dive. If the LHC really did crack open causality, if it actually altered the timeline over the last decade, we wouldn't have the scientific instruments to detect it.
No, we wouldn't.
Why? Because we are inside the very system that changed. You can't measure a change in the dimensions of a room if the ruler you are using to measure it changed along with the walls.
Exactly. Our only evidence wouldn't be a flashing red light on a computer screen at CERN. It would be a vague, collective feeling that things used to be different. A lingering, unprovable sense that reality doesn't quite match the historical record.
Whether you think this video is a piece of brilliant connective tissue linking quantum physics to the mysteries of human consciousness, or just an absolute masterpiece of internet speculation, it fundamentally changes how you look at that 27-kilometer ring under Switzerland.
It definitely reframes it.
It's currently sitting in silence, slowly warming up to room temperature. But I want to leave you with a thought to mull over today, something that builds on the science we've discussed but wasn't even in the video.
Oh, what's that?
Well, if we are living inside a reality that has been retrocausally modified by extreme quantum energy, and human memory is our only deeply flawed instrument to detect those changes, what if the everyday feeling of déjà vu isn't just a biological glitch in our brain's memory retrieval? What if déjà vu is actually our consciousness briefly perceiving a localized edit to the timeline, right, just as the newly rewritten reality settles into place?
Wow, that's a haunting thought.
It is. Until next time, stay curious.